Let's take a look at an example that we actually explored in our previous section and determine whether or not it's possible for this graph to have an Euler path. So in this example, the Navy Region Southwest, or NRS, is a division of the United States Navy. So below is the graph showing the states who had a common border based upon what we did in our previous section. So I just repeated one possible version of the graph model. Now the Secretary of the Navy wishes to visit each of these states. Is it possible for him to travel to these 6 states and cross each common border exactly one time? If yes, we're going to determine 2 such paths. If not, explain why not. Now when they ask to cross each common border exactly one time, the exactly one time indicates that you're looking for an Euler path. Now it's possible that you could also find an Euler circuit. Okay, so the Euler circuit has the additional criteria that you crossed each border exactly one time and you started and ended at the same location, which in this case would be you started and ended at the same state. This problem didn't have the requirement of starting and ending at the same spot, but we'll answer that question about even if that's possible in this graph. At the very least, though, we're looking for an Euler path. Let's find the degree of the vertices in this graph. Now right here I have degree 3, so this Euler circuit is automatically out. Let's go ahead and find the degrees of the rest of the vertices. This vertex has degree 2, this vertex has degree 3, this vertex has degree 4, 2, and 2. So at this point in time there are exactly 2 odd vertices. So based upon Euler's theorem, this graph will have an Euler path. Now it does not then have an Euler circuit, so you're going to have to start and end at different states. We're going to have to start at one odd vertex and end at the other one. So maybe I'll go ahead and put those guys in red so you can see when you go to state a possible path, you're going to have to start at one of these odd vertices and end at the other one. Okay, so we're going to determine 2 such paths. So here are some possible paths. Alright, so maybe I start in Nevada, go to California, Arizona, maybe we go back to Nevada at that point in time. We missed it so much, we're going to return. Alright, then I'm going to go to Utah. So sometimes it's going to help to draw or number on these so you can see where you've been. So maybe I'll try to numbering on these. So we first went here, then over to Arizona, up to Nevada, and now I'm over here at Utah. So maybe we go back to Arizona at that point, then New Mexico, Colorado, and then back to Utah. So there is one possible path. I started at one odd vertex and I ended at the other one. A slightly different example, maybe from Nevada, we go directly to Utah. Maybe drop our luggage off there at a hotel or something. Okay, so maybe from Nevada we go directly to Utah, and then maybe we go to Colorado after that, then New Mexico, then to Arizona. Okay, now keep in mind we have to end at Utah, so at this point in time if I go to Utah I won't have any way to get out of there because I can't retravel an edge I've already traveled. So from Arizona we'll go to California, then to Nevada, back to Arizona, and then finally we'll end at Utah.